Hey guys, I'm going to go over the multiple choice for question problem set 1.2. The reason why I'm doing this is this is an AP class, so multiple choice questions are literally half the test. The exam is set up in two portions. If we do in fact take the typical one, it's a 3-hour exam, so there's 90 minutes of just multiple choice. So we always want to be able to gain techniques and skills on multiple choice. Let's take a look at question number 40. It says, for which of the following would it be inappropriate to display data with a single pie chart? So kind of use what we learned in class. I made a pie chart of this first example. So it says the distribution of car colors for vehicles purchased in the last month. So a pie chart, a single pie chart would make sense. You've got some categories and you have frequencies. So you only have one variable. So that's a situation where you have one categorical variable in a single group. So hopefully that helps you kind of visualize why A is acceptable. And so many of these are going to be acceptable. We're looking for the one that is not. B says the distribution of unemployment percentages each of the 50 states. So when I hear that percentage, I'm like, wait, I don't have frequency. Like, yeah, B is like kind of confusing. So let's look at C. It says the distribution of favorite sports for a sample of 30 middle school students. So I'm hoping you can imagine here we could have baseball, softball, volleyball, football, and the frequency. And that these frequencies would add up to the 30 middle school students. And all we need to do is change the labels. So we definitely like C because it fits this circumstance. D, shoes worn. This is the same thing. We can change the categories from blue, light blue, orange, and white to flip-flops, tennis shoes, boots, high heels, right? E says the distribution of presidential candidates. So this we could change, instead of the colors, we could change to Buttigieg, Biden, Trump, Bernie Sanders. It makes sense that we could change the categories to candidates' names and add up the frequencies of people that want that candidate. So I'm definitely feeling good that my answer is B. Okay, so when you do problems with multiple choice, in order to get full credit, now I'm usually pretty easy the first couple assignments, but to get full credit, you can't just put B. You have to say B because. So give me some kind of a because. And you could also say B because it's definitely not A, D, or E, and then I guessed. But give me a because. Now let's look at 41. It says the following bar graph shows the distribution of the favorite subjects for a sample of 1,000 students. What is the most serious problem with the graph? So when we look at the graph here, I think we're noticing it starts at 100. So the widths are not messed up, so that's okay. But the vertical axis should start at 0 rather than 100. This is making it look like English is twice as preferred over science, and in fact, it's not even close to twice. So this is misleading data. D. 42. When we look at 42, it says the Mavericks won the NBA championship in the 2010-2011 season. In this two-way table, we see these outcomes for the games. Which of the following would be the best evidence that there is an association? So in our notes, we said we can go to Staplet and type in a two-way table. So let's take a look at this data. And so this is like the one categorical data, multiple groups. So I typed in wins and losses, 100 or more, fewer than 100, right? So it just perfectly matches my table. I typed in the data, and we said if the two segmented bar graphs look alike, there's no association. So when we see here, we realize, there must be an association. So we ask ourselves, why? Well, notice the dark blue, which is the win, the dark blue is 90% when they scored over 100 or more points. But the dark blue is only 40% when they scored fewer than 100 points in that game. So because these two bars are not exactly the same coloration, which means they're not the same proportions relative to each other, then that's what's telling us there is an association. So let's take a look at what fits the bill there. And again, I need some type of a proportion, right? So I like D. The Mavericks won a higher proportion of games when they scored at least, 90%. They won 90% of the time when they exceeded 100 points, but they only won 40% of the time when they won fewer. And so D is a fit. So you want to say D because, and your because could be an explanation like I explained, or it could be a simple picture like this, or it could be a combination of both. All right, one more question. 43. Center up my picture here. All right, it says the following partially completed two-way table shows the marginal distribution of gender and handedness for a sample of 100 high school students. So this is a lot like the last question. We have one variable and two groups, male and female. So remember, this instance says if there is no association between the gender and the handedness, what would be this value? Okay, so let's think this through based on the knowledge we collected. I took the liberty of typing this in, right? And I said to myself, wait, I know that if there's no association, these two graphs will look the same. But it looks like a lot more females were surveyed than males. And so again, it has to do with the proportion. So let's take a look here. It says out of the total amount surveyed, 40% of the people surveyed were male. That means for the graph to look identical, I need 40% of the 10 left-hand dominant folks to be male. Well, that 40% of 10 is 4, right? And 60% of 10 is 6. So that's how I got the idea of typing that there. And again, I really just used multiplication. So I'll show you that, but to come up with that. And then I used what we call the complement rule to kind of work backwards. So if that number is 4, and I know the X and the 4 add up to 40, that's how I figure out that must be 36. Okay, kind of a little puzzle. I can work my way around. Now, I definitely have confirmed here that even though I have fewer men in the survey than women, I do have a situation where there's no association because the two segmented bar graphs look exactly the same. So I'm going to write out how I would have done that by hand, because I think some students might need a little direction there. So if in fact there is no association, then we see here that 40 over 100, or 40%, right, were male. And we notice 60% were female. So if in fact there is no association, meaning even if you tell me you're male, you're still going to have, I have no better chance of guessing. So that must mean out of the 10 that were left-handed, of the 10 that were left, 40% of the 10, and of means multiply, 40% of 10, right, is 4. And 60% of 10 is 6. So then working backwards with the complement rule, if we know we talked to a total of 40 men and 4 were left, then this is where we get our answer 36. So that is C. Thanks for joining us, guys. I hope that helped clear up any confusion. Have a great night.